This lesson is about z-test by using critical values. Let's talk about z-scores first. For normal distribution, X follows normal distribution with the mean mu and a standard deviation sigma. We will make z equal to X minus mu over sigma. We got this standard normal distribution. Z follows normal distribution with the mean 0 and standard deviation 1. We can use a calculator to get critical value of z-test. Inverse norm, area, mean 0, standard deviation 1. Assume critical value is k. Area equals probability of z less than k. There are three types of tail test. Right tail test. Area will be significance level alpha. So this critical value k equals inverse norm. Then probability of z less than k equals this part of area, which is 1 minus alpha. 1 minus alpha, 0, 1. This area, also called the rejection region. When z value is in this region, reject HO. So when z greater than k, reject HO. When we have a left tail test, means H1 mu less than certain value. This is alpha, significance level. So k equals inverse norm alpha 0, 1. This area also called the rejection region. When z is in this region, reject HO. So when z less than k, reject HO. When we have a two-tail test, this area will be alpha over 2. This area will be alpha over 2. This area is a rejection region. This area is a rejection region. We will have two critical values labeled as key 1, it's a key 2. Basically, key 1 equals opposite of key 2, or key 2 is the opposite of key 1. So key 1 equals inverse norm alpha over 2, 0, 1. Key 2 equals inverse norm 1 minus alpha over 2, 0, 1. When z less than key 1 or z greater than k2, reject HO. Try to remember the relationship between H1 and what kind of tail test. When H1 is mu greater than certain value, it's a right tail test. When H1 is mu less than certain value, it's a left tail test. When H1 is mu, it's not equal to certain value, then it's a two-tail test. Guided practice 1. For a sample of n equals 25 data, we know that x bar equals 40, s sub x equals 3. Given that the standard deviation of the population is sigma equals 2.96, there is a claim that mu less than 39. Conduct a test for this claim at 5% significance level by using critical value. Since standard deviation is given, we will use z-test. First step, HO, H1. Always remember HO is dealing with the equal sign, so mu equals 39. H1, mu less than 39. From mu less than 39, we know this is a left tail test. We can draw the diagram like this. This is a K. This area is alpha equals 0.05. So second step, we will figure out this K. K equals inverse norm. Area is 0.0501. Let's go to calculator to get this critical value K. Menu 6, go to 5. 3 inverse norm, area 0.05. Enter, enter. Answer is negative 1.64. Third step, we need to figure out z value. Menu, go to 6, go to 7. Z-test. It's not data. We are given stats. 39 is mu 0, sigma 2.96. X bar is 40. N is 25. H1 is mu less than 39. Then enter. We got z equals 1.69. From calculator, you also got p-value 0.954. Step 4, we can draw the conclusion. Since z greater than this k is negative 1.64. And z is here, 1.69. Since z 1.69 greater than negative 1.64, it's not in the rejection region. We do not reject HO. So rewrite HO at significance level. If you use a p-value, you will get same conclusion. P-value 0.954 greater than 0.05, we do not reject HO. Go back check. The claim is mu less than 39, which is H1. We do not reject HO, which means HO is true. H1 is not true. In other words, the claim is not true. So we can draw conclusion in this way. We do not have enough evidence to support the claim that mu less than 39 at 5% significance level